Little blue bar trying to get going. Zoom going to YouTube. Setting up your meeting for YouTube Live. Blue bar is halfway across. Done. Redirecting to YouTube.
Done and ready?
Yep.
I think we might be.
Are we on the air? I'm gonna assume we are. My name's Ronnie Heron. It is Monday, March 24th, and through the 30th, the end of the month, we have our 213th program. No, 212. We're going into our fifth year of the SBAU Astro Hour. It's a Monday morning vlog for our astronomical club called the Santa Barbara Astronomical Unit, SBAU. As I said, 5 years on the big screen, members and officers gathering together in our, I guess, men's dens and places in our house, all based at the Museum of Natural History. And we do like to scour the cosmos. We are this hour without our usual commander at the helm. Commander President Jerry has gone north at warp speed. And maybe I kind of thought he would join us, but we welcome Tom to run the show. And I'm your host. And ladies and gentlemen, we're going to talk this hour in program number 212 about the Big Dipper's handle. You look up there for a M63, the Sunflower Galaxy. All about asteroids this week. How many? Are they a threat to us? How big are they? Where are they? Lots of photos. Got another galaxy out in the night sky. Looks like a giraffe, but it's got camel in its name.
And that's not a galaxy, Ron.
It is. What did I call it? It's
a galaxy.
The galaxy looks like a giraffe.
No, the constellation.
The constellation.
Oh, gotcha. That's right. Galaxies don't look like giraffes. Ours looks sort of like a. Oh, never mind. Got a new comic.
Round,
Gentlemen, welcome aboard. Jerry is on assignment, Jerry Wilson, and we welcome Tom Cotton, who's married to the lovely Suzanne, a Renaissance woman, as captain of the starship this week. We also have Chuck McPartland with us, probably going to lead us through the talking points, our incredible outreach coordinator in charge of all the events. Pat is his wife, merchandise manager, and new treasurer. Let's see who else. Tom Whittemore joined us, former Westmont College.
Yep.
And his wife, Maureen, is in the background somewhere. He edits our newsletter. Tim Crawford has a new laptop. He's a Mac guy, longtime member, and lens expert, married to Karen. And finally, Bruce Murdoch, who comes in two parts on our screen.
Yeah.
Bruce, how's Bonnie doing? She getting around okay?
Well, she has had her last course of chemotherapy for a while, and that just knocks her flat.
Okay, gotcha. We're going to see you in 2 weeks on our Friday the 4th, I guess. We're going to convene in once again in Farron Hall. There we are. Tom is incidentally our webmaster, and you got a quick shot. Was that our web or our newsletter?
Yeah, that was a website. Yeah.
Oh, okay. I'll just tell you right now that it's the return of Joseph Farah, a young man who overflowed Farron Hall years ago. Does anybody remember? Was that pre-COVID? During the pandemic?
2 years ago.
It was years ago.
It's only a couple of years ago, I think.
It was post-pandemic, Ron.
Was it post? Seems like it was longer than that. Well, he's going to visit the SAG-A, supermassive black hole at the center.
Ron, it's SAG-A star, where that star is an asterisk. SAG-A is just a radio source.
Okay, well, what do they call the black hole?
SAG-A star.
Yeah.
They consider black holes a star.
No.
No.
That's just the notation. It's an asterisk, and you pronounce it star. SAG-A star.
Right.
Is it the only black hole we have a name for? The one in our galaxy?
No.
Give me another one somewhere. Do they name them in other galaxies?
Yeah.
There it is. Joseph
There's
Farah.
one.
Virgo A.
Yeah. 87. Right.
Yeah.
Okay. That's why I'm here. I'm the guy that learns, that knows nothing. You guys are all experts. And I'm proud
Are
to
you
be
ready for
around
the
with.
funnies?
Yeah, let's do the funny stuff. Jerry, our president, forwards to us silly science cartoons and a few thought provokers like
I
this
like
one.
this one. Yeah.
Here are three gentlemen on screen. We talk too much about Schrodinger's cat. Okay, this is about yeah, quantum, not enough about Schrodinger's wardrobe. Is he the one on the right?
Yeah.
Yeah, that's Schrodinger.
Oh, don't tell me he doesn't wear shorts. I hate those.
I don't know
Okay.
what, there must be a different name for those things. Pantaloons? What?
Kind of like
Oh,
culottes or
right.
something.
You got long
Yeah.
socks. Okay, that was
He's-
Schrodinger. He came up with the cat thing. You know who the other two gentlemen are?
I don't know.
Not Neil and
Dirac.
Bohr?
Is that Dirac on the left?
Dirac is on the left.
Yeah.
Okay, they're all involved with quantum, which was not Albert Einstein's
Could be
favorite topic.
Heisenberg in the middle, Chuck.
Yeah, could be.
He's got a
All
Prince.
right.
But you'll
But
never
we're
know.
We're
Chuck,
uncertain,
Yeah,
right?
yeah, I was just gonna say you'll never know.
Yeah.
These guys, are these guys dead or alive?
They're goners.
Oh, they're all gone, yeah.
Only his cat died inside the box.
Well, we don't know that for sure.
All right, what's next?
All right.
Go to
I
the-
love the cow.
Yeah.
Okay, yeah. Literally, I've waited my entire lifetime to see that damn cow jump over the moon.
That's actually a repeat. We've had that
Yeah.
one before.
Yeah, I've
think
seen that
so.
before. Yeah.
Well, is that the moon at night or daytime? Okay, let's go to the distant past. In every artist's depiction of a meteor which caused the extinction of the dinosaurs, there's always one T-Rex looking up like, uh-oh, this is not going to be my day. That cannot be good. Always a T-Rex. Never a brontosaurus. Chemtrail conspiracy theory in a nutshell. Dad is holding his daughter and pointing to the sky. You know what, darling, this scares the hell out of me because I failed high school science. I don't know what that is. Contrails are us. Here's a American couple ready to go sailing or something. They're at the travel agency, and he asks, "Any place left where Americans might feel welcome?"
Yeah.
Don't go to Canada.
It'd be interesting to go to the State Department website and see what they say about other countries. You know how they usually warn you about going to other countries.
And times we are living in, travel agency.
Pretty bad.
Okay, year 1440. What is this? Johannes Gutenberg, who
Yeah,
invented
I like this
the,
one.
said, I've invented the printing press. Printing press says you're out of magenta. However, toner is cheap at that hour. That back then you could afford the damn toner.
That was 1440, huh? Way back
Yeah,
then,
they
huh?
use an oily ink, one color, black.
Is that right?
Yes.
Printed the Bible over and over again.
Mhm.
Okay, fascinating
And
stuff.
then we got
Here's Chuck's cat eclipsing, total eclipse, his black one over there. Well, that happens. All we need is the flag. And he puts it on and it eclipsed him.
Yeah.
All right, here is a guy coming out, I guess, of a time machine. You know, I went back to warn them, but they already knew and didn't give a darn. I'm just not going to say shit on this show. I'm sorry. I was confused. That's funny.
All right. I
stuff.
think that's in those.
Thank you, Jerry. Is there any more?
I think that's it for the.
That was it.
Okay, that gets us in a good mood. I have transcribed all of Jerry's notes, but Mr. Outreach, can you and our skipper at the helm, Mr. Totten, maybe the rest of y'all chime in? You want to, did I give you the title? Yeah, we're going to talk about asteroids on the night sky. I gave you the headlines already.
Yeah. So Jerry's first talking point was the sunflower galaxy. So this time of year, it's getting to where the orientation of the sky is such that the Milky Way is getting near to being just around our horizon. So you're looking up out of the plane of the galaxy. And so you see other galaxies easier. There's not as much junk in the way. And he's talking here about near the Big Dipper's handle, if you just come, you know, in the direction around which it curves and come down a little bit, you have several galaxies down in there. One of them is the Whirlpool Galaxy, but he's talking about M63, Messier 63 Sunflower Galaxy, which is near Cor Caroli. That's the bright star, the brightest star in the hunting dogs chasing the bear, which according to the Greeks keeps the sky rotating.
Mhm.
You guys can
Did
see
we-
this?
Yeah, it
Yeah,
looks
we-
good, Tom. Looks good.
Can we
So you
see the
get-
galaxy? Does it look like a sunflower?
Let's
Yeah, he's
zoom
got a picture of it in his
Okay, we'll come up on it here then.
in several wavelengths, actually. Okay, so the first picture is by the Hubble Space Telescope.
Just want to show how stellarium you can zoom in on, and they give you pictures of things.
Yeah, but let's do Jerry's because he has several different wavelengths.
Right. And
Wavelengths. You mean infrared and ultraviolet, different views?
Yeah.
Does it have a bunch of arms, not just 2 or 4?
Well, it looks like it has a bunch of arms because it's what's called a flocculent galaxy. It's fluffy looking, like cotton
sheep?
balls.
Like sheep?
Like sheep, yeah.
Thank God. I thought flocculent was a dirty word we couldn't say.
No.
You want to call up that flocculent sucker?
yeah, I'm coming there just a sec. Find it.
You know, you flock things, typically ceramics. You put glue on them, then you dose them in the flock, which is really short little cut fibers. And it gives it a nice footing.
Really? Never heard the word before.
Or you flock your Christmas tree to make it look like it's covered with snow.
Yeah, very different from flak.
Yeah. And weren't there flick and flack in early television?
Yeah.
Yeah,
Frickin' frack.
that's a frickin' frack.
Flocking the tree is short for flocculent.
You can't do
Spraying
that.
some sort
Well,
of.
I think of
they're
it more
related.
like a sheep, kind of like puffy, like a sheep.
Okay.
Here we go.
Yeah, well, that's
Whoa.
So there's the Hubble view of the
Okay.
sunflower galaxy, and it kind of looks like, a sunflower. So
Yeah.
hence the name. And you can see all the dark dust lanes, and then the sort of the more bluish in the arms. But the arms are a little bit obscured by all the dust.
Think it's about the size of ours?
Yeah, in that neighborhood. I mean,
100,000 light years across?
we're pretty good. We're
Okay.
pretty good size, but yeah, that's typical. And then there's his next one shows an infrared view, which really traces the dust in the spiral arms, and you can see it does have a fair number of spiral arms.
How far away?
Just like the Milky Way.
How far away?
It's gonna be in the tens of millions of light years. Let's see if he has that anywhere here.
Okay.
I've got 30 million light years in the
Okay.
Wikipedia here.
Okay.
And
what's interesting is there's a nice ring right around the core of the galaxy there, and kind of the core looks pinkish, but then you see this nice ring of dust around it.
Well, it's sure a bright center.
Yeah. Okay, so this is the ultraviolet view. So you can see there's probably foreground stars there, those big yellow blobs. Then you can see a fair amount of UV. And that's showing up in the blue, really, because that's where the new stars are forming, and they give off more of the ultraviolet.
Are the yellow stars in our galaxy?
Yeah, they're probably foreground.
Okay, got it.
Yeah,
Raindrops on your windshield.
Ron, I was just going to say one trick I do when Tim and I do the solar viewing on Mondays.
Right.
The Palmer Observatory.
Oh,
There's a beautiful set of images of Messier 101 up in Ursa Major. And I always tell people from left to right, it's cold, medium, and hot.
yeah. But the only one we can
This is hot, Ronnie.
The only one we can see with the naked eye is Andromeda. These all require telescopes, right?
Yeah, it's pretty dim.
Yeah, Andromeda is the big one you can see with your eyes. I mean, you can see the large and small clouds of Magellan. Some people, you can see the Triangulum galaxy on a good night if you know where to look. There's a couple you can see, but this you won't see naked eye.
Yep.
This is magnitude 8.6, I think it said, which is fairly bright. Yeah, fairly bright for a galaxy, but not naked eye. It's binoculars. And so this is just sort of a lead into this whole part of the sky is full of galaxies over there in the Virgo cluster and Coma Berenices and that part of the sky. So this is the time of year that people go out and hunt for that stuff.
Yeah.
Now you have to be kind of late at night, but
all the galaxies out there in the universe come in all different angles, don't they?
Orientations, yeah.
We either look down on them or under them or sideways, edge on.
Yep.
We can look at M81 and M82 for a nice comparison. One is kind of edge on, and the other one's not quite face on.
Yeah, Tim had them in his scope on Friday night at Westmont.
Yeah, and Tessa had them both together on her Sea Star.
Yeah. Mhm.
Wow.
They're a nice view.
Oh, yeah.
So up there in Ursa Major, we do get a fair number of galaxies too.
I think it's always
101,
amazing.
One.
It's amazing to me that we didn't know there are galaxies outside of our galaxy just 100 years ago, it seems like,
Right.
right?
Yeah.
Right. Mhm.
Yeah, well, it took Hubble and Sleeper and those guys to start measuring the distances.
Mhm.
Henrietta Leavitt.
Yeah.
Well, she was part of the key, yeah, with the
Yeah.
Cepheid stars. So they
Can
could
we
see.
look at Can we look at galaxies and tell which way they're turning, which direction, counter?
Yes. Yeah, you just take a spectrum and you can see red shift on one side and blue shift on the other.
Yep.
That's cool.
Even if we're looking down on it?
Yeah. Well, less so if you're exactly down on it, but you're not all, it's rare to be exactly looking straight down on it. So
Does
there's always
this one-
some radial motion. And one of the did he do the Black Eye Galaxy later or not? Can't remember
No,
all the talking
is it
points.
2403 or something?
Oh, okay.
Isn't Black Eye is Black Eye M64?
That sounds right.
That sounds right. Yeah, there's another galaxy up there called the Black Eye that looks a lot like this, but in the area where we saw the dark dust lanes, there's a huge dark dust lane.
Mhm.
And it seems to have formed from the merger of two galaxies colliding. And when you look at that and do the radial velocity, what you see is one part of one set of stars and gas in the galaxy is going clockwise and the other set is going counterclockwise.
Whoa.
So
How in the world?
so you get bursts of star formation when the clouds collide.
Clouds collide.
Yeah, the clouds of gas in the galaxy.
Yes,
talking about-
M64 is the Black Eye Galaxy.
Yep.
That was one of Jerry's talking points. Why do most of the galaxies all seem to rotate in the same direction?
Are they all, did they mostly go clockwise? They seem to be, don't they?
You can't tell unless you do the spectral analysis. You just can't tell from the morphology.
So why did Messier name these 64 and 65? Then he went over to Leo and they became 65 and 66.
Yeah.
That's just the order that they were seen in his catalog.
Yep.
Or in some cases, the order of the time in which he discovered them, of course, because then he'd enter them in his catalog. But we went back and looked at that. It used to be only 90 something in the catalog. And then people looked back at his and Messier. I'm probably pronouncing it long, but
No, that's right.
Messier's catalog, because they were working together and they sort of added some that would have been different in the sequence relative to the dates they were discovered. So it went up to 110.
But sunflower is not an elliptical. It actually has arms in there. We just can't see
Spiral.
it.
Yeah, you can see them in that infrared view quite clearly.
Mhm.
I guess I don't remember that one.
All right, ready to go to asteroids?
Yeah, there's a lot on asteroids here.
Oh man, I'll say. I learned a lot.
And this is just one of the characterizations here of how you classify the asteroids. There are actually a couple of them, and they reuse some of the same letters, so you often have to specify which system you're using. But this is one, so they look at these asteroids. They're sort of leftover junk from the formation of the solar system. And the main belt is between Mars and Jupiter. But there's a whole bunch in the Lagrange points of Jupiter called Trojan asteroids. And there's, and of course, they've been scattered. They interact with each other and they interact with Jupiter and Mars, and they get scattered around. So you get near Earth asteroids and you get Centaur objects. There's a whole panoply of these things. And you also get a whole mixture of characteristics between comets and asteroids. There are things that are intermediate between them. So in general, you can think of an asteroid here, like he says, as rocky, metallic, or icy, but with no atmosphere. So they're not active. And from their spectra, you can tell if they've got carbon on the surface, or if it's metallic, or if it's silicates, like he's saying here. Primitive type, I don't know quite what this classification means for that, but usually the carbonaceous ones are considered primitive. Maybe it's ones that they can tell haven't been modified by impact that much. Q-type, similar to ordinary chondrites. Chondrites are like the vanilla version of a meteorite as far as rocky meteorites. And here this isn't explained very well. K-type spectrum resembles CV and CO. Those are different types of carbonaceous meteorites. And then the U-type is the catch-all, it looks like, in this categorization.
Well, Chuck, if your pet rock that you like to pass around at star parties that would make you walk like a duck,
yeah,
we're out there, which would it be?
That would be the M-type, metallic.
That would be the M, huh?
Yeah, because it's nickel iron.
Mm-hmm.
It's basically a chunk of stainless steel.
Okay, but are they also considered meteorites?
Only if they land on the ground.
Okay, no matter how big they are, they're a meteorite if they hit the ground.
Yeah.
They hit the air and disappear, they're meteors.
Well, meteor just refers to the visual aspect that you see, where they ram heat the air in front of them and it fluoresces. That's a meteor. And the thing that's making the meteor is called a meteoroid. And Jerry gave a definition somewhere in his talk here saying a meteoroid is something too small to be called an asteroid, that comes in and enters the atmosphere. But really it's fuzzy between them. Meteoroid just means it's something that's hitting the upper atmosphere.
When we pass into those radiants, those are meteoroids. That's the leftover comet tails, right? Not
yes,
asteroids.
Yeah, they're meteoroids. They're things that would cause a meteor. And you can think of them as tiny, tiny asteroids because they're particles of dust or ice.
Well, one of the things Jerry said that just amazed me was the whole total mass of asteroids out in the belt. And I imagine that the Trojans too would make up, what, 3% of our moon?
Yep.
Good Lord.
It's a small thing. You've got some of these internet conspiracy type guys that think it's, a planet that got destroyed by Nibiru or some such, Planet X thing. And really, no, it's just stuff that's left over, really primitive stuff. And it periodically forms into bigger things and gets crunched down into smaller things because there are collisions happening all the time. And that's just because Jupiter and Mars are constantly stirring it up.
And really, on that smaller scale, something can harden into something that solid and
well, the metallic meteoroids or meteorites or whatever you want to call them, the M types, they probably formed into a bigger body in the past, at least 100 miles or more across. And has enough internal heat from both gravitational collapse and radioactive elements that it melts and differentiates. And so the light stuff goes to the top and the heavy stuff goes to the middle. And that's where you get a metallic core. And then they get smacked by something and broken apart. And so you get a whole bunch of metal fragments. And we've visited some. This is Eros here, I think. And this was visited by a spacecraft that landed on it by the Near Shoemaker mission. We actually had the director of the Near mission come and speak to us way back when, back in the 90s in the club. And that was one of the first missions that was powered by ion thrusters.
Really?
They actually went and landed on this asteroid. And this asteroid is interesting because it's one of the ones that gave us our best first measurements of the exact scale of the solar system. Because it comes in close enough to the Earth that we could see a lot of parallax on it, and we could do some distance measurements. And of course, with radar, we bounced radar off of it, and we got some good measurements of the solar system.
Do we have the age of the solar system is about 4.5 billion years?
Between 4.5, 4.6 billion. I think 4.58 is the favorite
Well, it's
number.
older than dirt.
Older than dirt, yep.
But this sucker was named after the goddess of seduction.
God of love.
The god of love, Eros. It kind of looks like, well, now, never mind.
Kind of
This
looks like a
morning
boot.
I was watching, just an aside, I was watching this program that on TV, how the universe was created or something like that. But they had a really interesting discussion on the moon and how it got, the theories on how it got created. And it made me think about this asteroid belt, if it was the same age as the moon. And I'm guessing yes, right?
Well, it's even older than the moon because the moon formed subsequently from an impact, but
Maybe Ceres is the biggest chunk left over one, from one
Ceres,
collision.
well, okay, so if we back up to the one Tom had up just a minute ago, that's Ida and Dactyl. This is the Galileo mission was heading out to Jupiter, and they figured, oh, wait a minute, we're flying by this asteroid. So they took some shots of it, and sure enough, they found it had this little moon. So it's Ida and Dactyl, and that's pretty cool. I mean, it was the first moon discovered around an asteroid, and and what's neat is, the gravitational force is so, the gravitation is so small on this asteroid that you could jump all the way. You could exceed the escape velocity, and you could jump over to Dactyl if you were on that asteroid. But you got to aim carefully because it's a long way home if you miss.
You would think that the odds are of all the moons in our solar system that circle planets, some of the larger ones might have a little satellite going around them, but it never happened.
That's tough because the major body would interact with it too and tend to throw it out.
Oh, is that right?
It's tough to get some of these three body stable orbits.
Well, now the two moons of Mars, are they captured asteroids?
That was the usual thinking. Now some people think that they're debris from Mars from an impact that formed what's called the Hellas Basin in the southern hemisphere of Mars.
Okay.
And they're in decaying, Phobos at least is in a decaying orbit. It's eventually going to smack back into Mars.
Well, really, the only one of the four rocky planets is us that has a decent sized moon.
Yeah.
I mean, our moon is very large with respect to Earth, compared to other moons.
Yeah, we're like a double planet.
Yeah.
Is our moon bigger than Mercury?
No.
But there's a couple of moons out there around Saturn or Jupiter that are bigger than Mercury, isn't it?
Ganymede around Jupiter is the biggest moon. It's bigger than Mercury, and Titan around Saturn.
And
so this is Ceres, and this is the biggest asteroid, the first one discovered. And it's an ice ball. So it's in hydrostatic equilibrium. So it's got this spherical shape, whereas the rocky and metallic ones tend to be smaller, and there's not enough gravity to squish them down into hydrostatic equilibrium. So this is more likely something that's, I would think, left over from the grand tack when Jupiter and Saturn were kind of moving around and stirring things up. And this is something from the outer solar system that ended up in the asteroid belt.
Huh.
But it's in a nice orbit, so maybe it's something that originally formed there, and it just, it was cold enough that it hung together and big enough that it survived impacts. You can see it's been hit a lot.
right, but the ice you're talking about, the water is mixed with the rock, right? It's not one of those Enceladises or Europas.
Right. It doesn't have, well, I don't know if they think it has any liquid water underneath. It might, because there's stuff erupting out. You can see these bright white areas.
Right.
Those are like cryovolcanoes where some stuff oozed up from the inside and deposited bright salt deposits. So it may have some liquid underneath, but it's not getting squished and squeezed the way those moons are around Jupiter and Saturn.
Wow.
And that would help heat up the interior.
And they say they got more.
Why have the asteroids never coalesced into bigger bodies?
Because Jupiter and Mars keep messing with them.
Oh, okay.
Well, are they from different places? The Trojans come from a different source than the asteroid belt.
Well, we think Trojans are the most primitive, that they haven't left those orbits because they're pretty stable. So they're not getting messed with quite as much. So they're probably from the same source, ultimately, is the stuff that formed the solar system. They've just stayed in those places, whereas the stuff in the main asteroid belt has been jostled around quite a bit more.
Well, now there are asteroids that are at the Lagrange points of Jupiter.
Right, those are the Trojans.
Yeah, Trojans and the Hildas.
Well, the Hildas, yeah, the Hildas are more in the asteroid belt, and they share orbital characteristics with a big asteroid named Hilda, and they seem to be products of things that have smacked into Hilda. And they're kind of in the 180-degree spot, but that's not nearly as stable. Yeah, you can see that Hilda's triangle there where they're
right
out almost to the orbit of Jupiter. But that spot isn't nearly as stable as the 260 away from Jupiter.
Yeah, those are the two main Lagrange points.
Yeah.
Wow.
So yeah, this is a nice view of how they're spread out. And we have Trojans too, but not quite that many. And Mars apparently does. Okay, so we're finding Trojans are pretty common out there, but not a lot of them for the inner planets. Because we're close enough to each other, we interact too.
Let's not forget a bit about the Greeks.
Yeah, well, yeah, the one side of the Jupiter Trojans is called the Trojans, and the other side is the Greeks. But there are asteroids that are named after Trojan heroes that appear among the Greeks, and Greek ones that appear in the Trojans. So they're called the spies.
Well, if we find a big one in that belt, we should call it Helen.
Yeah.
I guess it's the same process on a stellar size as the rings of Saturn, right?
Yeah,
Anyway.
it's conservation of angular momentum from the cloud that formed the solar system.
Amazing.
Now, these have been perturbed, so you see some of them in high inclination orbits also. So some of them aren't right down in the plane. But when you project it like this, they all look like they're on a flat plane.
Wow.
And there's a whole lot of near-Earth asteroids. They don't really, not as many as there are in the main belt, but they don't show up well here because, you're sort of only taking the big guys here.
Well, you remember the big, was it a comet or an asteroid that broke up and it fell into Jupiter and left those black spots?
Yeah, Shoemaker Levy 9, that was a comet.
Did that come from the Trojans?
No. That came from out in the Kuiper belt or the Oort cloud.
So
probably Kuiper belt.
So it was a comet.
Yeah.
And comets
1994.
Yeah.
Comets pretty much have the extra stuff that aerates, becomes water vapor.
Yeah, they're active, so they heat up and volatilize. There are asteroids that have a lot of that stuff too, but they're just not active because they've got a crust that's formed over them or something.
Well, shoemaker levy broke apart into like 5 chunks.
Oh, there were 21 pieces. Yeah.
Really?
Because Jupiter's gravity, it got within the Roche lobe of Jupiter, and Jupiter ripped it apart. And so it hit us as 21 different pieces.
But we didn't see any one of them collide with Jupiter. It did on the other side, didn't it?
We did see it with views from the Galileo spacecraft.
Oh, we did?
Yeah. We saw those impacts, and then they rotated around, and we could see the impact scars, which was amazing to me. They lasted for months, and Jupiter's basically a fluid planet with 300-mile-an-hour winds. So it's amazing that these things made huge marks on Jupiter that persisted for so long. I mean, any one of those would have probably wiped out life on the Earth.
You suppose they get vaporized?
Oh, yeah.
They hit and vaporize.
Yeah.
Wow.
But they impacted Jupiter on the backside, side away from us.
Yeah. Kind of on the toward one of the limbs where we would have been barely able to see it. But yeah. So that's why we relied on Galileo for the images.
Well, that asteroid that's possibly going to swing by Earth but might hit our moon, that might be a light show to see.
Yep, that would be fairly spectacular. And another visual that Jerry had of the asteroids here, and in addition to Eros and Ida and Dactyl and Ceres, there's an interesting one there. He's got a view of Bennu.
Right.
So you
Getting
see this
there.
interesting shape to Bennu.
That the one that's what is it? Shaped like a
It's kind of a double cone, yeah, or
Yeah,
or diamond shape.
diamond. That's the
Yeah,
It looks like a briquette.
yeah. And so this is, when you see this shape, that's telling you it's a rubble pile, that it's only loosely bound and that it's rotating fairly rapidly. I think for Bennu, it's a 2-hour day, 2-hour rotation. And so just like when you're on a merry-go-round and you feel that outward seeming pull, these rocks migrate toward the equator as the asteroid rotates. And for Bennu, that was a big problem because we sent OSIRIS-REx there to do a sample mission, and pieces were getting thrown off at the equator. And so there's all kinds of stuff flying around. I have an actual GIF of that.
I got it on
Have you got-
Wikipedia, where they show Bennu rotating. You're talking about?
Yeah, and the pieces flying off.
Well, I don't know about pieces flying off though. Let's see. I've got
you
the road.
mean normally flying off, or because we hit it?
No, it's just because of its rotation. Okay, yeah, you're not really seeing them there, but you can see how there's just big boulders all over the place and chunks of stuff. So it took them a long time to find a flat spot where they were going to come down and do the sample. And yeah, Jerry didn't show it in there, but their sample probe that they had a long arm, and on the end they had something that was like a dinner plate. It was 12 inches across. And they stuck out. Oh, there it is. So there you could see briefly the stuff being thrown off. If you go back one.
Oh,
yeah.
Okay.
So that stuff's flying off, and they had to kind of hope not to get hit by that. So I think they stayed away from the equatorial region. And when they came down and they plopped this dinner plate in, they had a canister of pressurized nitrogen. Yeah, so there you can see the collector plate going down and touching the surface. And they fired this nitrogen because they didn't know, they thought this stuff was going to be kind of stuck together, and they wanted to blow some off and get it into their collection plate. And they landed at Nightingale, which is the one on the left. And this thing was so loosely bound that if they hadn't fired their retro rockets, they would have ended up embedded inside this asteroid.
Whoa.
And so as soon as they detected that they touched something, they fired the nitrogen and they fired their retro rockets, and they ended up leaving a crater 30 feet across on Bennu, because it's just like a ball pit at McDonald's or whatever. And they got much more sample, like, I don't know how much more sample size than they expected. It actually jammed the collector closure.
And they actually named parts of the surface?
Yeah.
Wow.
So here's showing their orbits. And so they're coming in for the collection.
I think this is just Bennu, how it orbits around the Earth and the sun.
Ah, okay. Oh, here we go. Watch this. When this thing hits.
Whoa.
That's where they left the 30-foot deep crater.
But Chuck, you were saying the stuff that was thrown off, was that from centrifugal force?
Yeah, from the rotation of Bennu.
Okay.
And so, it's looking like a fair number of these asteroids are rubble piles like this, because that stuff's constantly, there are collisions, and then the stuff reaccretes, but it doesn't reaccrete violently if it's a small collision. And so you end up with just these, like a bunch of sand flying in formation, basically.
Well, is that the stuff that came back and landed in Utah?
Yes.
That's the stuff. Okay. Wow.
And one of the missions was to now look at, we have these dangerous asteroids that could come in and hit the Earth, and you want to know if there's a way you can deflect them. And so one of the missions, he only mentions it briefly here, was DART, the dual asteroid redirection test.
Right.
So there were two asteroids. Well, there was an asteroid called Didymos, and it had a moon, a small moon orbiting it. And they had the moon's orbit very precisely measured. And so they took this DART thing that's like a refrigerator going 17,000 miles an hour, and they smacked it into the moon, which was called Dimorphos. And they wanted to see if they could change the orbit. And it was a rubble pile, and they had this huge blast when they hit, and it spewed out debris that's actually going to cause a meteor shower on the Earth in a couple of decades. And they changed the orbit by like 10 times what they expected to change it. So these impacts on rubble piles would be a good way to deflect an asteroid so it doesn't hit the Earth, if you know it's a rubble pile asteroid.
Just hit it and it'll veer a little bit.
Yeah. And if you do it far enough away, you only have to move it a tiny bit.
Does anybody remember that half-hour Twilight Zone show
Oh,
back in
yeah.
the 50s where the guy was sentenced to live on an asteroid and they'd have to fly a rocket in with his supplies, and there he is breathing and warm.
Yeah, not quite like that. But, you know, if you want to tell a story, sometimes you gotta.
That's true. Rod Serling had a hell of an imagination,
Yeah.
but
Yeah, he was good.
but
And
the-
Jerry also had a logarithmic diagram here of the asteroid sizes and their distribution, showing that it's kind of, if you're twice the size, there are only half as many of you and things like that. They obey kind of a power law. So on a log-log scale, you get a diagonal line. Yeah, there we go. That was that one with black. Unfortunately, Jerry did these as JPEGs. Oh, that's showing up pretty good. When I blow it up, it was unreadable, basically. So you can see how, you know, the bigger you are, the fewer there are of you.
well, have we gone to asteroid 3 Juno yet, or Vesta?
We've gone to Vesta.
Vesta's in there. It's at the very end of his talking points.
Yeah.
Currently in Librae. This is just out there outside of the belt, I guess. At the very end of his
That's all right. I
talking.
mean, we can compare the size of Vesta right here to Ceres.
I'll be damned.
And these, you know, this first set of asteroids that were found, 1, 2, 3, 4, and 5, were considered planets.
Really?
And quite a few of them were considered planets up until photography came along. And then they said, oh, we're finding so many of these, they're like rats. And so they redefined them and they called them minor planets or asteroids. And so that's the same thing that happened to Pluto, but it happened 200 years ago.
Is Pluto as big as Ceres?
Pluto is roughly twice the size of Ceres as far as
Okay.
diameter.
How about Charon, its moon?
Charon is about the size of Ceres, like 600.
So they sort of do a dance around each other, don't they?
They are tidally locked. So the same face of Charon always faces the same face of Pluto.
And then it's got a couple other moons, doesn't it?
It's got 5 total.
Hey, Ron.
Yes, sir.
Yeah, if you're from Brooklyn, that's how you say Vester.
Vesta. Yeah.
Or Boston for that, you know.
Yeah, it's close to South End. Yeah.
That's right.
So Vesta is kind of walnut shaped, and there was a mission that orbited that. Dawn? Yeah, Dawn took a look at both Vesta and Ceres and was in orbit. And as far as sample missions, that OSIRIS-REx that went to Bennu and took the big sample, that was kind of the Japanese space agency tried 2 similar missions to Itokawa and Ryugu, which Itokawa is probably on here, very small. Those are comets down in the lower right, but it's probably up here. It's shaped kind of like a bowling pin, or like I tell people when I'm doing an asteroid show, it looks like dog poop rolled in gravel. And it has kind of an elongated shape. And then they went to Ryugu, which is a rubble pile that looks just like Bennu, but scaled down. And they tried to bring back samples, and they had bad luck. The first one, Hayabusa 1, failed on re-entry somehow and destroyed it. And then Bennu and the one to Ryugu, they successfully landed, but they were contaminated with Earth bacteria, so they can't do some of the organic compound investigations of it, like OSIRIS-REx. We saw all the nucleic acids that you need to make DNA and RNA in Bennu. So that's very interesting. And lots of signs of what are called phyllosilicates, I think. So stuff that's been modified by water. So very interesting results from that.
Wow.
And these are asteroids. This picture that's up is asteroids that have been visited by spacecraft, leaving out Ceres, and also including a Kuiper Belt object there. You can see Aerokoth, which is the one that was visited by the mission that went by Pluto. That's the one that looks like a snowman, two pieces stuck together there in the middle. Aerokoth. It's down and it's in the middle between the two biggies there. Yeah.
Can I throw out one last question about a movie we all saw growing up, and that would be Disney's Fantasia. You remember the scene about life evolving on the Earth, set to Igor Stravinsky's Rite of Spring? Does anybody remember that?
Yeah, I do. I do.
Okay, it went by pretty fast. But at the end of that segment in Fantasia, which was my introduction to classical music, it shows the dinosaurs struggling in the heat and falling in the sand. Nothing about an incoming asteroid. Or I was wondering if 1939, when that movie was made, that theory about 65 million years ago hadn't been proposed yet. Does anybody know?
That's true. It had not.
No, it had not.
So Disney didn't even realize.
That came up in the 90s when you had two, father and son, the Alvarez family, found this layer of iridium and carbon products all around the world.
Yes.
They dated it back to the KT boundary, which was the extinction boundary. And they said, I think a big asteroid impact happened, and you want to look for a crater that's about 120 miles across, that's age somewhere around the world. And nobody knew of a crater that size. But it turns out that in Mexico, Pemex had been doing seismic studies to find oil deposits in the Yucatan Peninsula. And they saw a series of concentric rings around a crater just offshore of Yucatan that was about 120 miles across. And there was a guy who went to the talk by the Alvarez family. He was a geochemist or something, and he went to the talk by the Pemex people. And he said, you guys should talk to each other. And sure enough, that's how they identified the Chicxulub impact. That was the one we think is responsible for the bad news for the dinosaurs.
Yeah, Ron?
Yes.
Just getting back to the Rite of Spring. Did you ever try to count that?
I'm sorry, did I ever what?
Try to count it. Try to count the rhythm in that thing. It's a real exercise in chaos.
I do know that it was premiered in about 1913, and half the audience walked out.
Yeah,
they didn't care for it. I thought it was rather weird and strange, but it's got some good parts to it, especially when the Stegosaurus.
Yeah, the guy who conducted it was Charles Munch, and when he realized how much people were basically rebelling against the first performance, he did it again.
Well, tell me about this Iridium. It's an element, but I never hear anything about it. You know the number?
It comes from outer space, right, Chuck?
Yeah, it's common in meteorites.
Yeah.
Well, what is it? Is it a metal?
It's a metallic element.
Would it
It's a satellite.
Could it replace aluminum or?
Satellite.
Well, it's denser than aluminum, so you don't want to use it. And it's also rarer in the Earth's crust.
Yeah.
Okay. Interesting.
And because it's dense, it tends to sink toward the core.
Well, Wow, yeah, density of 22
Yeah, and as
compared to
Tim
1
would
for
know,
1.
on the periodic chart, it's right next to Upsidasium.
Atomic number
Here we go.
77.
Yeah, so the Alvarez family, those two, they knew that it was something that was fairly common in meteorites, but not in the Earth's crust, and so that
Right,
was why they.
the older one, Chuck, was a physicist, and the younger one was a geologist, basically.
Yeah.
Yeah.
Really?
Yeah, Luis.
The name Iridium, you don't know where that came from?
No, just
Iridium comes from rainbow somehow.
right. Iris, right? Iris.
Is it heavier than iron?
Oh yeah.
Uh-huh.
So it's made during the explosion of a
Yeah,
nova.
you want to say more dense.
It's more dense, and it's made in collisions of neutron stars mainly.
Yeah.
Oh, no kidding. Really? Where do we get stuff like californium and fermium?
Those are made inside
Those are made.
nuclear reactors.
Those are made by us, huh?
Yeah.
Yeah, they're
they
created.
don't
They don't
last
live
very
very
long.
long, Ron.
They half-lives of a few seconds, I guess.
No, it's even less
Pieces
than
of
that.
seconds.
Really?
Yeah.
Doc, is there any connection to the Iridium satellites?
No more than there is, between the star Sirius and Sirius XM radio.
Okay, okay. I
And
missed those.
there's
those
an predicted island of stability of heavy elements that's a little bit beyond the big heavy ones we've been able to make so far.
Mhm.
People right now are trying to smash a whole bunch of heavy nuclei together to make something that would be really massive nucleus and be stable. So that'll be interesting.
Wow.
Yeah, we could make it upsidasium.
Yeah. Or unobtainium. Or really
Unobtainium,
toughium.
right? Yeah.
But your uraniums, there's a couple of uraniums, aren't there? They're made in those collisions and explosions, right?
238, 235.
Five, right?
Hmm.
And then Jerry had, two asteroids in the sky, although he only mentions really, what has he got? He's got Juno and Vesta. Okay, so this is another one of those things where it's pre-dawn in the sky this time of year, because they're in Ophiuchus, Scorpius, and Libra area in the sky.
Let's see.
So he's saying Juno's magnitude 10.7. So of course you'll need a telescope.
Mm-hmm.
Here's Zeta Ophiuchi, and he gave a chart for that. And it looks like Tom's got a different chart here.
Yeah.
Stellarium, just
Yeah.
Mm-hmm.
So it doesn't look like it's in a very busy star field. It might be. Okay, so there you can see Zeta just to the left of it. If you zoom in a little bit, Zeta Ophiuchi there is, okay, probably Yed posterior.
Mm-hmm.
So if you follow that kind of to the, looks like south here, or southwest, southeast, southwest, you can bump into this asteroid. It's the kind of thing where you're going to want to use a planetarium program to make a chart of the nearby neighborhood, so that when you look in your eyepiece, you'll know that's the one. Either that, or you go from night to night and look for the one that moved.
Yeah. And since you're in the morning, Chuck, I was out looking for Venus this morning. I didn't quite get it.
Yeah, it just was at inferior conjunction yesterday, so going to be tough.
Yeah,
there's a picture at spaceweather.com of it.
Okay. But when it does become visible for folks, they should look above the rising sun, okay, and to the left, which would be to the north.
Great.
look at the sun, then look north. Yeah.
Well, before the sun comes up, if you have a good horizon.
Yeah, we tend to not have a very good horizon.
Yeah, you're blanked out, Chuck.
Yeah.
So
So
go ahead.
I was going to say, Jerry also mentions Vesta, so it's in Libra, and he typoed, or didn't, he left out the name of most of the name of the star. It's Zubanesh Shamali. Actually, he had put in Zubanesh. Zubanesh Shamali, and then there's also Zuban el Janubi.
Mm-hmm.
And those are the two sort of balance plates of Libra, the scales. And their names actually come from Arabic for southern and northern claws of the scorpion. They used to be back in ancient Sumeria and that time, they were the claws of the scorpion.
Yep.
But the Romans saw Virgo up at the top here as Astrea, the goddess of justice, and they figured she needed some scales. And so they stole some of the stars from the scorpion and they made Libra the scales.
Yeah.
Oh, interesting.
So zodiac means band of the animals because all the constellations were animals or people. And then the Romans threw in this thing that wasn't either one. So it's the only constellation that isn't an animal or a person.
Huh.
Yeah, we get the name Zoe basically from the root Zoe.
In the zodiac, that is. There's a bunch of non-animal things in the southern hemisphere, and there's Crater the Cup on the right up here. So, but it's the only one in the zodiac that's not an animal or a person.
Right. Zoe is Greek for life, basically.
Yeah. And all those little red dots are galaxies, so you can see the Virgo cluster there.
Yeah, yeah.
So this is the time of year to hunt that stuff. And actually, late March, early April is when you do a Messier marathon, and you try to go out and see all 110 Messier objects in one night.
It's nice to see the galaxies in Leo here too.
Yeah.
Do you suppose if you ran into a hardcore astrologer in a bar and they ask you your sign and you said Ophiuchus, would they know what?
Chuck could say that.
Well, you know, there's all kinds of sects in astrology too. There are even some of these, you know, yo-yos that try to include all the asteroids too.
Really?
So give me a break, you know.
But what is the story on Ophiuchus? Did it get screwed out of its place on the zodiac?
No, it's the precession of the Earth's axis has moved so that the sun spends more time in Ophiuchus than it does in Scorpius.
Yeah.
So since the creation of the zodiac, the ecliptic has kind of moved because of the Earth's axis.
Really? Okay. And what represents it on the screen here? Which one of those?
It's a serpent bearer.
The fellow holding the snake, Ron. You see the
That's
snake?
Ophiuchus?
Yeah, that's him.
He's supposed to
that's also
represent
serpents.
Yeah, there's serpens cauda and serpens caput, the head and the tail of the snake. Or sometimes now people just say, oh, there's serpents, just one, but it's traditionally two.
Yeah, Ron, do you see that the star at his head there, Ras al Hag? You see that, Ras al Hag? Anytime you see Ras from the Arabic, it means the head. Okay.
Really?
In Hebrew, it's Rosh, Rosh Hashanah, head of the year, start of the year.
Oh.
So that's the head of the one who bears the serpent.
Yeah.
But Ophiuchus sure sounds like an ancient curse word to me.
Well, he represents Aesculapius. So he was the mythical Greek physician. And they used to think that because snakes shed their skin, they lived forever.
Yeah.
And so supposedly he learned the snake secret and he was making people immortal. And the gods got a little ticked off at that. So they threw him up in the sky.
That's what happened to all these people, Chuck.
Yeah.
They get thrown up in the sky.
Well, that looks like the interior of the planetarium where we'll be meeting in a couple of Fridays at 7. And we'll be back, I guess, the same crew, right? Next Monday morning. Since our beloved president is on assignment and God knows where. We'll get into April.
Eugene, Oregon. He's up in Eugene.
Up in Eugene. I think he probably spent the night in the Bay Area because we got an email from him at about 10:30 and he left at noon yesterday.
He spent the night weeping because Arizona beat Oregon in basketball yesterday. And that's where I went to school, Arizona.
Well, gentlemen, it's always good to see you and I learn a lot and thank you very much. I'm sorry to say we don't need you, Jerry. We're doing fine without you.
Yeah, thanks, Tom.
We'll see you guys next week for number 213 in the merry 5th year.
Thanks, everybody.
Thank you all.
Bye-bye.
Goodbye.
Bye.
Bye.